Good afternoon, everyone. We are going to start our discussion in few minutes. No need of screenshot of anything. It is going to be uploaded once the class is over. Don't be tensed further. No need. Okay, once again, welcome back for everyone. First, I am discussing for 30 to 40 minutes that newly added title in the EC syllabus. After that, we'll go back to our yesterday's discussion because some of them purely get EC. They are not willing to attend the class. Those who are not willing, just for 30 to 40 minutes, I am making a review. It is not a new topic. Already we have done this in sampling and reconstruction. Just I am making a review of the topic. Just listen for 30 to 40 minutes. Okay. All you know, just I am making a review. What is the meaning of this topic? Discrete time processing of continuous time signals. Once this topic is over, we'll go back to our yesterday's discussion, sir. Impulse invariant bilinear. Again, we are repeating that. So don't be tensed for that. Just 30 to 40 minutes, I want to make a review of this topic, which we learned under sampling theorem, which is given as a separate side heading this year for ECE syllabus. Okay, listen. What is the meaning of this word? Discrete time processing of continuous signal is, actually this technique involves 3 steps. First, continuous times signal must be converted to what form? Discrete time signal. Second step, process the discrete signal by using a system. Process the discrete signal by using a. Third step is, the processed discrete time signal must be converted back to continuous time signal. That is what we studied as interpolation. Converting the sampled spectrum from the sampled spectrum, recovering back original spectrum, we studied as what, sir? Signal reconstruction, also called as interpolation. First step is sampling concept. Third step is interpolation. We already know these concepts. But as we studied, we are using ohm symbol for analog frequency, omega symbol for digital frequency. Ohm symbol for analog, omega for digital. Okay. So what is this discrete time processing of continuous signals? Let me recollect the points which we have learned already. We know a discrete signal can be obtained by using a sampler that opens and closes the switch for every ts seconds. In the coming slides, either I use a T or TS, both corresponds to sampling period only. Both are corresponding to sampling period, sir. Either use capital T symbol or TS. So an ideal continuous to discrete time converter, what it contains? An ideal continuous time to discrete time converter. First, the continuous signal. XCT means continuous signal is processed through a sampler. Physically, it is a sampler. with certain sampling period to get the discrete form. So what are the basic things it contains? Sampling period of t seconds and sampling frequency of 1 by t. What is the respective analog sampling frequency? OMS equals to 2 pi by t radian per second. Ideally, it is called as continuous to discrete converter. Practically, it is an A to D converter. That is what we learned as sample and hold circuit. Practically, it is A to D converter. Ideally, it is C to D converter, continuous time to discrete time converter. Ideal form is C to D. Don't be tense when the class is going to end. For GATE ECE, next 30 to 40 minutes, once I complete that, filter designs, rest of the things, maximum by 4:30, we may complete. Listen the class, concentrate the class. So ideally, this is called as continuous to discrete converter. Practically, it is called as A to D converter. For reconstruction also, we know the technique. Observe here. Suppose this original black signal is the analog signal we have, sir. How to pick the samples of that one? We try to multiply by impulse train or not. So this is like x0, negative side, x of ts, x of 2ts, like that. How to take the ideal form of impulse here in discrete form? We are representing like a discrete impulse or not? We are representing like a discrete impulse. This we know from sampling theorem concept. What is the ideal impulse train mathematical relation? We know, sir. Sigma minus infinity to infinity del of t minus nts. So again, I am repeating sampling theorem only, nothing new. Listen. So the ideally sampled signal is product of continuous signal and periodic impulse train. Ideally sampled signal is product of continuous signal and periodic impulse train. What is periodic impulse train? General form, sigma minus infinity to infinity del of t minus nts. So here we applied the product property of impulse xt into del of t minus t naught means, what is the answer? We know, sir. X of t naught into del of t minus. Based on that, in the place of t, we can substitute nt here. Based on multiplication in time domain means we know application of frequency convolution. In our derivation also, we applied the same property. x1t multiplied by x2t means what will happen to their spectrums? 1 over 2 pi x1 of j ohm convolved x2 of j ohm. Ohm for analog. So when you multiply in the time domain convolution, we know this is the formula, standard formula, spectrum of ideally sampled signal. Spectrum of ideally sampled signal. Suppose we are assuming the reference spectrum as triangle. Impulse train spectrum is another impulse train that we know. Reference spectrum, that band limited spectrum like this, sir. If we are assuming the band limited spectrum as omen, there I used omega m symbol in our derivation. Impulse train spectrum is impulse train. We observed oversampled spectrum is valid or not. To avoid aliasing, OMS must be greater than or equals to 2 times. How we studied this point in our discussion? In our sampling theorem, we studied that as omega naught greater than or equals to 2 times omega. But instead of omega, now we are using ohm symbol for analog without confusion. Omega for digital, ohm for analog. But undersampling leads to aliasing problem. We know that undersampling leads to aliasing problem. Again, from equation 1, I have taken equation 1 as it is in this slide. The sampled signal is sigma minus infinity to infinity xc of nt del of t minus nt. If I take Fourier transform for this expression, just recollect everyone, what is the Fourier transform for shifted impulse? What is the Fourier transform of shifted impulse, sir? E power minus j omega t naught. E power minus j omega t naught. So when you try to take Fourier transform now, Fourier transform now, what will happen? Del of t minus nt Fourier transform is e power minus j ohm tn according to this. This is neatly looking like our DTFT definition or not. Just make a comparison. In the beginning of this slide only we discussed xc of nt is represented as what's that? xn. So x of n e power minus j omega n. Based on this, what is omega and ohm t relation? Omega equals to ohm t. Those who have attended yesterday's session in impulse invariant technique also, what is the relation between analog and digital frequency we have taken, sir? In IIT technique, omega equals to ohm into t, linear relationship or not? So it follows that how equation 2 can be further adjusted by comparing these two equations. The sampled continuous spectrum is nothing but DTFT observed at which frequency? Omega equals to ohm t. So the sampled spectrum formula again I repeated, but in the place of ohm, what I substituted? Omega by t. In the place of ohm for analog, I substituted omega by t. We know DTFT spectrum periodically repeats for every 2 pi or not. Therefore, Xe power j omega is just a frequency scaled version of sampled analog spectrum with the frequency defined as omega equals to ohm t. This is called as normalization. That is what I mentioned. In the process of converting analog to digital frequency, as our digital frequency is limited for minus pi to plus pi range, we are doing normalization or not? We are doing normalization of the spectrum. Only don't bother about the mathematical expressions. See the sequence of steps. Don't bother about the expressions. Here we are observing how the sampled CTFT will appear like DTFT. How the sampled CTFT spectrum is appearing like discrete time Fourier transform. Then how to reconstruct the samples? Means we used an ideal filter or not? We used an ideal filter there. This dotted version is an ideal filter. So that rectangular spectrum in the time domain, if you take ideal reconstruction filter as rectangular spectrum, what is the time domain function nature, sir? Once you take inverse Fourier transform, it is looking like a sinc function or SAV function or not. So once you convert continuous to discrete, that is our first block diagram. Here we are converting discrete signal back to continuous signal. So this is called as D2C converter. Discrete signal converted back to continuous signal. Apply X of n to sequence of impulse train, then use a reconstruction filter. In our oversampled spectrum also, what we have done, sir? In the signal reconstruction in the oversampled spectrum also, what we have done? We used an ideal low pass filter, then we observed a practical filter is needed or not for signal reconstruction. So what is the reconstructed signal relation? Sigma X of n into HR of t minus nt. What is the reconstruction relation means? Sin pi t by t by pi t by t. How you got that? The inverse Fourier transform of this one, you are all aware of sin a t by pi t. Sin a t by pi t means, what is the Fourier transform answer we have written, sir? A rectangle from minus a to plus a. A rectangle from minus a to. Similar way, if you take this rectangular pulse in frequency domain, the time domain function is sin pi t by pi t. This I substituted in this formula HR of t minus nt. HR of t minus nt means that sync pulses are repeated or not. That sync pulses are. So this is the reconstructed signal. In the process of reconstruction, every signal xn is multiplied by SAV function or sync function, n plus 0, n plus 1 like that. The shifted version of sync functions respectively. So what is the combined block diagram of discrete time processing of continuous time signal is? First we require C2D converter, that is called as a sampler. First we require C2D converter, that is called as sampler. Then we require D2C converter, our previous discussion. This is a D2C converter, discrete time to continuous signal, that is called as signal reconstruction. Middle extra what we are using? Discrete time system, because here discrete signal must be processed to a new form of output. That is generally represented as what, sir? H of e power j omega. You know that DTFT discrete system is represented as h of e power j omega. Correct or not? We feel that the middle block is an LTI system. No need to feel. Impulse response or frequency response means strictly that concepts are valid for which systems are LTI systems only. So LTA behavior of the system is depending on two factors here. One factor is what? Discrete time system must be LTI. Input signal must be band limited. Input signal must be band limited because our sampling theorem condition is applicable for band limited signals only. Sampling rate must be high enough so that any Eliaser components are removed by discrete time signal processing. Everyone recollect what is the advantage of oversampling. When you take more number of samples, if you increase Fs, Ts decreases, automatically sample to sample gap is decreased or not. So when you take more sampling rate, high sampling rate, Eliaser components are removed by this discrete time system because sample to sample gap of discrete signal is reduced. Sample to sample gap of discrete signal is reduced. So this is the general block diagram of discrete time processing of continuous time signals. In jet transform, two problems I solved like this. I hope some of you remembered the concept. X of t given to sampler. Later on we used a digital filter. Then we used a ideal low pass filter. There I have taken ideal low pass to recover back our continuous signal. That only today's build-up is what? C2D converter is sampler. Digital filter means discrete system. This discrete time to continuous converter is ideal low pass filter. The 2-3 models, that type of models only you are going to get in the exam. Nothing new today. I am discussing C2D converter is ideal sampling. D2C converter is what? Signal reconstruction. Assume both are having the same sampling period. Here and here sampling rate is same. That is our assumption, sir. Here and here our sampling rate is same. So when you recollect from fourth equation, x of e power j omega is this formula. But if you want to reconstruct the signal, our output discrete sample must be multiplied by SAV function. Our output discrete samples must be multiplied by SAV function. All these mathematical equations don't bother. In the textbooks, they will use so many mathematical expressions. Concept we have to understand. Concepts only we have to understand, sir. Okay. All this is we studied in sampling. Today, what I want to show is there we followed omega symbol, but we know ohm for analog, omega for digital. Ohm for analog, omega for digital. This the first block is ideal sampling concept. Last block is signal reconstruction. Middle block is what? Discrete time system. Discrete time system. Hz also we can take, sir. Just like that I have written. H of e power j omega, you can write that as digital filter transfer function. Hz also we can take. Okay. How the signal reconstruction is done? Observe here. This is our original signal. The sampled version of this one is like this. What I mentioned just now, we are reconstructing each sample by using a sync pulse or not. This expression, we are reconstructing each sample by sync pulse. So first you take h of t into, what is h of t expression we have written? Sine of, see that slide? Pi into t minus nt by t divided by pi by t into t minus nt. When you are taking first sample n equals to 0, it is simply sine pi t by t, first dotted version. Everyone see my cursor. When you are taking n equals to 0, our original signal is multiplied by sine pi t by pi t. If you take n equals to 1, what will happen? Sine of pi into t minus t, that is the second sync pulse. Sine of pi into t minus 2t, third sync pulse. After picking all the peak amplitude levels, we are in a position to recover back our original signal as it is. This is called as ideal band limited interpolation. What is the reason of using the word ideal? Rectangular spectrum. Physically not realizable. It is an ideal filter or not. For that reason, what is the practical version of the samplings we have learned, sir? Zero order hold sampling, first order hold sampling. I hope you have remembered all that. Zero order hold circuit, how you have drawn? Rectangular pulse of width t with sync spectrum. What is first order hold circuit? Triangular pulse with sync square spectrum. Correct or not? Triangular pulse with sync. This is ideal band limited interpolation. The reason is it is due to rectangle. Rectangle in time domain becomes sync pulse. So this is ideal reconstruction. Practically with circuits we are using a zero order hold circuit and first order hold circuit we are using for recovery. Zero order hold and first order hold. The questions that may be possible for you. What is the ideal band limited interpolation graph? What is the ideal band limited interpolation graph in time domain? It is looking like which function? Sine pi t by t form. Sine pi t by t by, correct or not? This is one possible question. Okay. 2-3 examples I'll solve in jet domain. How to convert continuous signal back to again continuous type of output. 2-3 models. That type of questions are possible. Today I want to discuss some more examples. Just go through it, sir. Some more examples. Observe here. Discrete time implementation of ideal continuous time band limited differentiator. Every one of us know what is d by dt Fourier transform J ohm. Actually, we habituated to j omega. Now it is represented as j ohm. This is the continuous frequency response. Normally, it is there for infinite range. Normally, that continuous frequency response is there for impulse range. But as we are performing sampling, since we are considering the relation of discrete time processing of continuous signal, automatically inputs must be band limited or not. If the input is band limited, system must be band limited. So I am taking that as effective. Effective means whatever is required. Is j ohm for the range mod ohm less than pi by t. Why I used that? Observe here. We have taken triangle for what range? Pi by t to. We have taken that rectangular spectrum for what range under reconstruction minus pi by t to pi by t or not. So for that range we are limiting. Everyone knows how to draw this graph. 0 to pi by t positive RAM, 0 to minus pi by t like this. Substitute ohm place. This is magnitude, sir. Modulus of j ohm. What about the phase angle? Positive analog frequency plus pi by 2, negative frequency is minus pi by 2. But how this is modified to discrete form? This is analog form. What is the discrete form? Omega equals to ohm t. That is the relation we know. So it becomes j omega by t for mod omega less than pi. Again, I have drawn the discrete form of that one. So in the continuous domain, when you have d by dt xt, what is the equivalent digital filter response? What is the equivalent digital filter response? J omega by t, that curve I have drawn. When you solve this in the time domain, you are going to get this answer. How we got that answer means, let me tell you outline. Direct answer I have written, sir. The inverse DTFT definition, every one of you know. What is the inverse DTFT formula? 1 over 2 pi integral minus pi to pi. Original spectrum, how we have selected the formula? J omega by t e power jn omega d omega. Here we are applying integral UV rule. I feel omega like u, the other one v. I feel omega like u, other one v. So further enjoyment, j by 2 pi t. First u integral v means what you are writing? Omega e power j omega n divided by jn minus differentiation of omega is 1. What is double integration of exponential, sir? E power j omega n by j omega n whole square. For the limits pi and minus pi, substitute and solve, you are going to retain this answer. So continuous case differentiator is d by dt xt, for which the spectrum is j ohm. But in the discrete case, what is the impulse response form, sir? Minus 1 whole power n by nt. How the question can be framed? For a ideal differentiator, continuous case, what is the equivalent discrete impulse response? So these are the mathematical steps. For an ideal differentiator in continuous case, what is the equivalent impulse response of discrete system? Minus 1 whole power n by nt. This simplification you do, substitute omega plus pi and minus pi, 100% you are going to retain this answer, sir. 100%. Okay. Next one, just 3-4 examples I am giving. These are 100% possible in the coming year. If they want to introduce from the new topic, the problems, whatever the models I have given here, 100% they are possible. Listen carefully. So consider the system shown in figure. Same system. This is looking like what? This complete system is looking like what, sir? How to process the continuous signal using discrete time processing or not? First a C2D converter, then a digital filter, then D2C converter. First question is, if xt is band limited to 5 kHz, what is the maximum value of t to avoid aliasing in C2D converter? Highest frequency 5 kHz means what is the Nyquist rate required, sir? 10 kHz. Highest frequency is 5 kHz means D2C converter is low pass filter only. D2C converter is low pass filter only. Okay. This is also correctly speaking under sampling process we used anti-aliasing. Under reconstruction we used anti-imaging. There only we said both are low pass filters or not, sir? If the highest frequency is 5 kHz, sampling rate required is how much? 10 kHz Nyquist rate. So to avoid aliasing, what is sampling period asked? 1 by t milliseconds. Opposite to this or not? T becomes 1 by 10 into 10 cube, 0.1 milliseconds. Second question asked is, if sampling rate is 10 kHz, what will be the cutoff frequency of original continuous time filter? What is the cutoff frequency of digital filter, sir? Pi by 8. What is the relation between omega and ohm? Same formula, don't be tensed. 2 pi f by fs, this way we have written there. That is ohm by fs means ohm into T. Nothing new I have created, sir. Same formula, omega equals to ohm C into T. What is the digital cutoff given? Pi by 8, ohm C. Time period, sampling period is mentioned as 10,000. So 2 pi into 625, what is FC? 625. Funny thing is, first bit is 2 times FM concept. Second bit is what? If you know digital frequency and sampling period, get analog frequency. This type of simple questions will be asked. Okay? Simple models. Another model. I hope everyone recognizes this point. First bit is based on Nyquist rate, 2 times highest analog. Second bit is this formula, omega equals to ohm into T. T means sampling period here. Omega equals to ohm into T. Let HTD denote the impulse response of LTA continuous time filter and HDN denote the impulse response of discrete filter. H of T continuous system, H of N is discrete system. Then it is asked for instrumentation. They will mix all the questions. Don't be tensed, sir. For instrumentation, they are going to mix even signals with analog, signals with controls mixed. For you, what is important, we can't say. That too, emotionally, they have 2 new subjects also this year for you. So you listen. You listen. You cannot avoid anything. If continuous signal is a decaying exponential, determine the continuous time filter frequency response. Just recollect what is decaying exponential Fourier transform. Already we know e power minus at ut. Answer is what? 1 by a plus j omega. Here we are following ohm symbol. 1 by a plus j. But second bit, what is mentioned? Sample the original analog impulse response. HDN equals to T times HC of NT. What happens if I replace small t as NT here, sir? T into e power minus a NT ut. This is looking like a power n un spectrum. What is a power n un spectrum? We know 1 by 1 minus a e power minus j omega. That way I have written the answer. Roughly I have drawn the frequency response from minus pi to plus pi. This is a rough curve which I have drawn for the range minus pi to pi, periodically repeats. Everyone recollect, those who have attended yesterday, it is looking like, again, impulse in style or not, continuous to discrete form, T plus NT. Continuous to discrete form means it is looking like our IIT Technica, impulse invariant technique. Come on, friends. Observe here. This is another model. Continuous signal is processed through C2D converter. Later on, it is given to a digital filter. H and H e power j omega means digital filter, for which all this information is given, sir. First bit asked is, for this system, what is the maximum allowable value of T? He wants the sampling period. What is the maximum sampling period if aliasing is to be avoided? Highest frequency 2 pi into 10 power 4. Ohm C number is 2 pi into 10 power 4. Ohm C number is 2 pi into 10 power. What is sampling rate condition? Ohm S must be greater than or equals to 2 times highest frequency, 2 into 10 power 4. In terms of sampling period, what we'll say? 1 by 2 into 10 power 4. To avoid aliasing, sampling period must be how much? Less than or equals to 1 by 2 into 10 power 4. It is less than or equals to 1 by 2 into 10 power 4. Xc of j omega equals to 0 after certain range. Why it is 0 after certain range? In our derivation, we have taken a band limited spectrum that covers from minus omega m to omega m or not. More than that, we are not taking. So this spectrum is also limited for certain range. After that, it will be 0 only. Analog signal, once it is to be processed through sampler, it must be band limited. So we have to choose band limited spectrum only, sir. Second bit asked is, find impulse response of the system. Find Hn. Everyone recollect our convolution formula. Sigma x of k h of n minus k. See the cursor. Sigma x of k h of. But this expression is given in the question as what, sir? T into sigma xk. Directly the output expression is given as T into sigma xk. I am writing this accumulator as xn convolved sigma del k. Everyone recollect first class. Of n is sigma minus infinity to n del k. Running summation of discrete impulse is unit step sequence. That is the reason I have written this as un, sir. So now the answer is looking like T xn convolved un. So by comparison, what is impulse response? Directly you can say T times un. In the question, that fellow has stated that output is T into accumulator. Output is T into accumulator. Compare with our convolution definition, sigma xk h of n minus k equals to the given expression, sir. So this can be, accumulator can be adjusted as what? xn convolved sigma del k. We clearly know sigma del k is un, so h of n is T un. Last question is, what is the steady state response? What is y of n as n tends to infinity in terms of input spectrum he wants? Final value of output means, what is final value of output? As you got y of n equals to now xn convolved tun. Xn convolved tun, and that is a given expression. What happens if I apply limit n tends to infinity here? T into sigma minus infinity to n xk, but n place what you are substituting? Infinity. Area under the spectrum means, area under the signal means where spectrum is taken, sir. Everyone recollect the DTFT definition. X e power j omega equals to sigma xn e power minus j omega n. But as we want sigma xn, area under the signal means taking spectrum at 0 or not. So what is the steady state output in terms of x e power j omega means T into x e power j0. T into x e power. All the bits are very funny and easy. They are not that much tough. So don't feel you are going to get very difficult questions or a new topic we discussed today. Nothing new we discussed. Whatever we know, I repeated. Whatever we know already, I repeated. But why I asked you to listen the class carefully is to observe the difference in analog and digital frequencies. Ohm symbol for analog, omega for digital. So CTFT, DTFT, they are interlinked. CTFT, DTFT, they are interlinked. Let me repeat this question one more time. The last example. This is the given data with the highest frequency 2 pi into 10 power 4. First question asked is, for this system, what is the maximum allowable value of sampling period if aliasing is to be avoided? To recover the continuous signal from discrete form, T must be less than or equals to 1 by 2 FM. Highest frequency 10 power 4, less than or equals to 1 by 2 into 10 power 4. Second question is, output is, he has mentioned as this expression T into sigma xk. Write the given expression as convolution formula sigma xk h of n minus k and compare with the given expression, because you want to know what is impulse response. Find hn means what? Get the impulse response is the question. So what I have done, sir, I adjusted accumulator as xn convolved sigma minus infinity to n del k. We studied neatly summation of impulse is unit step sequence. T into un is impulse response. What is the last bit asked is, find the steady state value of output in terms of x e power j omega. So the final value of output means, what happens if I substitute n as infinity here, sir? It is looking like area under the signal. From DTFT definition, we know area under the signal means spectrum at origin or not. From the DTFT definition, area under the signal means spectrum at origin. Just 3-4 models only I solved. The same way you are going to get the question, but all are linked to only one formula. Two formulas are main for you. One is what? Omega equals to ohm into T. Second is what? Sampling rate must be greater than or equals to 2 times highest analog frequency. Last 4 examples which I have shown here for you. Last 4 examples which I have shown for you, they are all linked to these formulas only. So just I asked you to attend the class today, this topic, especially discrete time processing of continuous signal. For what purpose is? Only to know the difference in analog and digital frequency symbol omega ohm. From where I selected this topic is question for some fellows. This is the title, discrete time processing, signal processing. Oppenheim-Schaffer. From the topic I have discussed. Discrete time signal processing by Oppenheim-Schaffer. Don't feel so many formulas are there. No need to worry about that. Whatever we know in sampling, that concepts only we repeated. Whatever we know in sampling, that concepts only we have repeated. You have a confusion in the second point, sir. What is the confusion? Find the impulse response is the question. Already has given output expression. Listen carefully. Already has given output expression. We clearly know output is convolution of input and system xn convolved hn. Just recollect the discrete convolution formula sigma xk h of n minus k. This expression is given as what for us? T into sigma xk, sir. We know this is accumulator. Jet transform also we used the word accumulator. Sigma minus infinity to nxk is accumulator. That I adjusted as xn convolved this one because xn convolved ln is xn only. X of n convolved ln is. Everyone can recognize this is unit step sequence. Running summation of impulse we studied as un. So TUN is extra. If you compare xn convolved hn form, this is nothing but x of n convolved hn form. By comparison, hn is simply what? T times un. H of n is simply T times un. Okay? Only comparison, sir. Compare with convolution formula. Okay, this is a small topic. Don't be tensed. Whatever the 3-4 examples I solved, under convolution property of jet transform, 2-3 examples I solved, solve that questions only. It is more than sufficient for EC fellows. Discrete time processing of continuous signals. Those who are willing to attend the class, that is continuation of yesterday, they can stay back. Yesterday we discussed impulse invariant bilinear. The topic I am continuing. Pure gate AC fellows, if they don't want to listen, they can leave also, no problem. On Sunday, 9 o'clock, I am going to start DFT. On Sunday, I am going to start DFT concept, advanced happy Vinayak Chaudhary for all of you, those who are leaving. Rest of the fellows stay back, instrumentation bachas and those who are willing to attend the class. Yesterday's topic we are discussing. You want flash? Okay. I'm giving 5 minutes time for the fellows who are willing to leave, sir. First slide, 18th slide. Come on, friend, each slide I will keep for 10 seconds. Those who are willing to leave. Digital filter design is there for instrumentation. IES exam, ISRO exam. 19, 20, 1, 22, 23, 4, 5, 6, 7, 29, 30, 31, 32. Immediately once my class is over, this will be uploaded. Don't be tensed for that. The fellows who want to stay back, they can stay back for attending yesterday's class continuation. Rest of the fellows, pure gate EC fellows. I want only gate exam, no IES, no ISTO, any other competitive exam, they can leave. Pure gate EC, they can leave. I don't want to write any other exam, they can leave, sir. EC, I am saying instrumentation, we are continuing. Instrumentation fellows, stay back, we are continuing. Today class at what time, sir? 2 o'clock it started, na? Arey brother. Till 4:30 I mentioned, na? Yeah. I will slow my speed, ma. As it is a discussed topic, slightly I have gone fast. Now you see how much slow I will go. Sampling reconstruction, discussed topic, na? That is the reason slightly I moved fast. Now you see. Let us continue our mathematical enjoyment, what we have done yesterday. Let us continue our enjoyment. Let me recollect what we studied yesterday. Let me recollect the concept. Slow and steady wins the race, I know. Ahmad bhai, I know. Aap bhi karo. For engineering services exam, complete syllabus, whatever I have written in the first class, it is there, sir. Filter design, DFT, FFT, everything is there for engineering services exam. Okay. Let me recollect the concepts we learned yesterday. First, we studied realization structures. Direct form 1, direct form 2. Once you know digital transfer function, how to draw the structure means realization structure. After that, the fourth step we observed is how to convert S-plane to jet plane. First, we learned impulse invariant technique. What is the procedure we followed? Analog transfer function we are taking. First, it is converted to analog impulse response. Then we obtain the digital transfer function by using jet transformer, not sir. What are the stupid formulas we derived there? 1 by s plus alpha equivalent to what? 1 by 1 minus e power minus alpha ts z inverse. What is the second expression? S plus a by s plus a whole square plus b square means s plus a by s plus a whole square plus b square means a relation like this: 1 minus e power minus at cos bt z inverse by 1 minus 2 e power minus at cos bt z inverse plus e power minus 2at z power. The third form we discussed there is b by s plus a whole square plus b square. Only numerator changes. E power minus at sin bt z inverse by denominator as it is. Denominator. But what is the disadvantage we observed for the impulse invariant techniques are? As analog and digital frequency are linearly proportional, it is limited to design of which filters only? It is limited to design of which filters only? Low pass and band pass filters. Low pass and band pass filter. High pass and band stop filter cannot be designed by this method. High pass and band stop filter cannot be designed by this method. Okay. That is about impulse invariant technique we learned. What we learned under bilinear transformations are? What is bilinear transformation concept? It is a one-to-one mapping. Wherever SC is there, what is the replacement? Wherever SC is there, what is the replacement? 2 by t into 1 minus z inverse by 1 plus z inverse or not? 2 by t into 1 minus z inverse by 1 plus z inverse. One-to-one mapping we observed, but what is the relation between analog and digital frequency we got, sir? Ohm equals to 2 by t tan omega by 2. Ohm equals to 2 by t tan. We call this as which effect? Warping effect. Warping. So to cancel that warping effect, what we are doing? We are using pre-warping concept. How I remember the formula? My life is signals here. My body contains full of signals only. I hardly remembered last 10 years. Apart from signals, no other subject I have discussed. Hardly. Maybe some advanced signal processing techniques, some guest lectures I may have discussed. You practice, you will be better than me 100%. No one is zero. When I studied for the first time, I am zero. Now I remember the formula because almost every day I will discuss this. When we used to have regular classes, sir, average 15-16 batches I used to teach per annum in Hyderabad. So automatically you will remember. If you are habituated to the things, everything will come to you only. Okay? Don't get more emotional for that. One fellow's doubt is why impulse invariant cannot be used for high pass. Yesterday I have given explanation. Let me clarify that also. The same example I am discussing one more time. H of S equals to S by S plus 1. This is the high pass filter we have taken, sir. In impulse invariant technique, to convert S plane to jet plane, compulsory we require one of this formula. Compulsory. After partial fraction enjoyment, it is 1 minus 1 by S plus 1 after partial fraction enjoyment. If I want to apply impulse invariant technique, for 1 by S plus alpha, we have a formula, sir. 1 by 1 minus e power minus alpha ts z inverse style, we have a formula. But 1 in the Laplace domain, no equivalent term in the z domain. For if you take one number, there is no equivalent term in z domain. The two, 1 in Laplace domain corresponds to impulse. The inverse Laplace of that one is impulse. To convert continuous to discrete, what we have done, t place nts. Can you replace t as nts here? Meaningless. Continuous impulse is different, discrete impulse is different or not? Okay? You cannot substitute t place nts here. For 1, there is no equivalent expression in z domain. That is the reason high pass and band stop filters cannot be designed by IIT. High pass and band stop filter cannot be designed by impulse invariant technique. Warping effect neatly I have explained. Na? The non-linear graph, analog and digital frequency. Just a minute. I have added new things in the slides. I don't want to disturb them. I'll go to new slide. Just a minute, sir. Ohm equals to 2 by t tan omega by 2. This is the relation we got. How to understand warping effect means, tan curve is roughly like this. Suppose I have taken the highest digital frequency omega as pi, tan pi by 2 becomes infinity or not, sir? In impulse invariant technique, we mentioned that we try to maintain equal strip width of how much? Each fixed strip width is 2 pi by t. They are spaced equal. But if you try to project that frequencies onto this graph, if you try to project the same frequency ranges, analog frequency range onto this graph, sir, what has happened? What has happened now is, we are not going to get equal spacing now because it is a non-linear graph. And that too, see the cursor, sir, lower frequencies in the analog domain are now looking like higher frequencies in the digital domain. Lower frequencies in the analog domain now becomes higher frequencies in the digital domain. They are somewhat squashed up. This is called as warping. Warp means bent type of characteristics. Bent type. So to cancel this effect, we are using pre-warping, take the opposite characteristics. Like compounding we are using in communication subject. To cancel that effect, we are using pre-warping procedure. Okay? Why it is high pass filter? What ma? Filters also, you are not attended that class? What is limit s tends to 0 h of s here? 0. What is limit s tends to infinity h of s? 1. Starting 0, ending 1 is high pass. Only for filters I have discussed 2 classes. DTFT, jet transform also. 2 classes. Okay. See, 4th step we observed how to convert S plane to jet plane we observed. But from where analog transfer function came, that point we are checking now. From where analog transfer function came, I am doing some mathematics. Everyone listen carefully. I am doing some mathematics now. The first form of filter we are selecting is Butterworth filter. The first form of filter we are selecting is Butterworth filter. Butterworth filter characteristics are like this. It is having maximally flat response. It is having maximally flat response in both pass band and stop band. It has flat response in both pass band and suppose I have taken a analog filter with frequency response like this. Listen everyone carefully. Listen everyone carefully, sir. If I am taking analog filter like this with magnitude level, it has flat response in pass band as well as stop band. The magnitude square frequency response given by Butterworth is this formula 1 by 1 plus ohm by ohm C whole power 2n. How you got that formula means you ask Butterworth, he will tell you. That is not our emotion now. How to find the order and cutoff frequency of the filter, which is our second step. How to find the order and cutoff frequency of Butterworth prototype filter. That point we are checking. Listen carefully. I can write exactly at ohm p what is the magnitude level we have. Del p means mod h of j ohm whole square equals to 1 by 1 plus ohm p by ohm c whole power 2n. Ohm place I substituted ohm p means what is the magnitude levels are del p square. Similarly 1 by 1 plus ohm s by ohm c whole power 2n equals to del s square. When I substitute the exact frequency, I can take the respective gain or not. When I substitute the exact frequency, I can take the gain. Just to rearrange these expressions, I can write the first expression as 1 by del p square minus 1 equals to ohm p by ohm c whole power 2n. Drag del p square in the denominator, subtract 1. Nothing new I have done. Drag del p square in the denominator, subtract 1. Similarly, what about second expression? 1 by del s square minus 1 equals to ohm s by ohm c whole power 2n, sir. Assume this as equation 1, this as equation 2. Equation 1 and 2. Listen, 2 divided by 1. If I perform division of equations, ohm s by ohm c divided by this means what you are left with? Ohm s by ohm p whole power 2n equals to right side. This divided by this, sir. Right side 1 by del s square minus 1 by 1 by del p square minus 1. If I apply logarithm both sides, here, log a power x can be written as x log a or not. Log a power x can be written as x log a 1 by 2 logarithm of 1 by del s square minus 1 by 1 by del p square minus 1 log ohm s by ohm p. By using this stupid formula, we are in a position to get the order of the Butterworth filter. To get the order, what are the 4 specifications that are available to us, sir? Pass band, stop band gain as well as pass band, stop band frequency. 4 specifications are available. By using this stupid formula, we are in a position to get the order. Okay? That is what directly I have provided in this slide. Slightly I'll increase the size. Maybe it is not visible. Let me increase the size, sir. Okay. Still it is light. Maybe our fellows have not captured properly. So this formula, that formula only I have written here. 1 by 2 logarithm of 1 by del s square minus 1 divided by 1 by del p square minus 1 log ohm s by ohm. How to get ohm c? We should get order and cutoff or not. Or what is ohm c from equation 1? Everyone see here, see the cursor. If I take 2n this side, sir, it becomes whole power 1 by 2n. If I take 2n this side whole power, so ohm c equals to ohm p divided by 1 by del p square minus 1 whole power 1 by 2n from equation 1. From equation 1, take 2n this side, that becomes 1 by del p square minus 1 whole power 1 by 2n means you got, to get order this relation, to get cutoff this relation we need. That is what in this direct formulas I have given. Maybe it is light. Chod do. The other point of observation here is, After knowing the transfer function, listen here, sir. After finding the order and cutoff, we are in a position to know transfer function, which is this answer. First order answer is s plus 1. Second order is s square plus root 2s plus 1. Like that, direct formulas are available. This is given by Butterworth, not by me. Let me explain how we got that answers also. Let me give clarity how that fellow has written all these answers. Equate the denominator term to 0 and solve, you will get the answer. Equate the denominator term to 0. Observe here. What is our denominator term here? 1 plus ohm square by ohm c square whole power n equals to 0. We know on the j ohm axis s equals to j ohm or not. Means s square is what, sir? Minus ohm square. Minus. So how this expression is modified? 1 plus minus s square by ohm c square whole power n equals to, so minus s square by ohm c square whole power n is minus 1. I should write minus 1 general solution as e power j 2k plus 1 into pi. Why I am writing that form? N number of roots are there. N means whole power n means n number of roots are. Further enjoyment, minus s square by ohm c square equals to, take n this side, e power j 2k plus 1 into pi by n. Still we have extra negative sign minus 1 that I can write as e power j pi, from which the answer for s is plus or minus ohm c, e power j pi you take on that side, e power j pi by 2, e power j 2k plus 1 into pi by 2n. Because of this stupid expression, we got the denominator. Because of this stupid expression. In this expression, k varies from 0, 1, etc. n minus 1. Just for clarity only, I am giving explanation. Only for clarity. By equating the denominator term to 0, we are in a position to get this answer. Let me check for first order the answer directly. If I take n value 1, k is 0, everyone see the cursor, n value 1 means k is 0. N is 1, k is 0 means this is also e power j pi by 2 or not, sir? E power j pi by 2 into e power j pi by 2 means e power j pi minus 1. That is what s plus 1 are. What is the meaning of this table? Prototype low pass filter having ohm c 1 radian per second. Original formula contains ohm c. But you can take that pole location only if you assume ohm c as 1. For a given question, ohm c is not 1. For that reason, you require the stupid formula. For a given question, cutoff frequency need not be 1. For that reason, we require the stupid formula. Correct or not? Plus or minus ohm c e power j pi by 2 into e power j 2k plus 1 into pi by 2n. Substitute k place 0, n place 1. See here everyone, k place 0, n place 1. This is e power j pi by 2. This is e power j pi 2 mean e power j pi. E power j pi is minus 1. 1 by s plus 1 is the answer. Okay. Ohm c, if you assume 1, then only this table is valid. So this table is given for which filter? Prototype low pass with cutoff 1. Second order, third order, any order you can find by using this stupid table, which is not created by me. Butterworth has given the tables. Our main observation is how to find n and ohm c. For a Butterworth filter, how to find the order and cutoff? By using these stupid formulas. Okay. Wantedly, if that fellow has asked to find the order of Butterworth filter, you have to remember why I equated the denominator to 0. Are bhaiya, n means order na. To calculate the order, then only I will know the pole location na. It is a all pole filter. Kya pooch rahe bhaiya? Afternoon jyada ka hai? By equating the denominator to 0, then only you will know the pole location na. It is a all pole filter, sir. It contains only denominator. It contains only denominator. Why it is all pole filter? What is the numerator? Frequency response contains 1 by something na. It is a all pole filter. It is all pole filter. Okay. Only for your understanding, now I am solving a lengthy problem. Be ready with your calculator. This is not a gate question, just for your understanding. What for? We have learned the formulas. Only for understanding, sir. I am solving a big question. Everyone be ready with the things, sir. Calculator, everyone be ready first. Are you ready with calculator? Okay. Listen. If you are all ready, I will start one simple model for explanation. If you are all ready. Just for your understanding only, I am discussing one question. Don't be tensed for that. Just for understanding purpose, sir. Just wait. I am making some adjustments. The files which I have deleted. So to get the order and cutoff frequency of Butterworth filter, we are using the stupid formula or not? Suppose Ohm's is 2, then you have to remember the formula. That only you are knowing now. Come on, friends. That point only you are knowing now. How the filter question is framed in the exam. How the filter question is framed. See here. Design a digital Butterworth low pass filter. BW means Butterworth. That meets following specifications. That meets following specifications. Mod HE power j omega is given means digital filter response is given or not? Mod HE power j omega is given means digital filter response is given. This is the data given. It will take at least 10 minutes. Don't be tensed. Everyone do the calculations with me. It is asked for us to design a Butterworth low pass filter that is satisfying these specifications. What data is known for as is passband gain number 0.707, stop band gain number del s 0.2, omega passband is pi by 2, omega stop band is 3 pi by 4. Okay, this is the data given. Yesterday we have written 5-step procedure. The first step there is, I am writing very neatly for you. Convert digital filter specifications to analog filter specifications. It is mentioned which technique to be followed in the question, sir? Bilinear transformation, BLT, bilinear. First we are converting the digital filter specifications to analog filter specifications. Okay. Abbo, very difficult question. Del P, what is the graph I have drawn in the first slide? 1 is the maximum magnitude level. Del P, pass band gain will be more or stop band gain will be more? See this Karuma, pass band gain is 0.707, maximum 1, ideal case. This is del S 0.2. That is also difficult. In bilinear case, what is the stupid formula, sir? Ohm and omega relation. Come on, friends. 2 by T tan omega P by 2. Omega stop band is what? 2 by T tan omega SP by. Yesterday only I discussed in the last example, when you are doing complete design, remove 2 by T or not. When we are doing complete design, remove 2 by T. Acha, your BTech 3-2, maybe they have copied from me. For fun I am saying. Substitute there. Tan pi by 2 by 2, tan pi by 4 is 1. Tan 3 pi by 4 by 2, tan 3 pi by 8 is 2.414. Please cross check everyone in radian mode. For a complete design, we can eliminate 2 by T because unnecessarily it will increase our maths. Luckily for my convenience, I have given sampling time 1 second, sir. Suppose sampling time is 1 millisecond. 2 by 10 power minus 3 means 2000. Very big number. Unnecessarily we are increasing the maths. In the problem ending, you will understand why I have deleted 2 by T. Wait. I hope everyone completed this. Convert the digital filter specifications to analog. Obtaining pass band and stop band frequency. Come on, friends. Everyone completed the first step. Second step is getting the order and cutoff frequency. We have to get the order and cutoff frequency. What is the order stupid formula just now we derived? Where I have derived? Second slide. Second slide, that formula is there or not? N equals to 1 by 2 logarithm of 1 by del S square minus 1 by 1 by del P square minus 1 log ohm S by ohm P. That means 1 by 2 logarithm of what is del P del S numbers already we know. Substitute there. Ohm S by ohm P, stop band by pass band is how much, sir? Logarithm of 2.414 by 1. Simplify and tell me which number you will get. I know the answer, you tell me. Make a try, solve with me. Show some emotion. Come on, friends. What number you got? 1.8 is the answer. Mr. PVS Srinivas, I don't know you have a doubt on you or on me. If they are not related to ECE, why I will discuss? You see previous IES exam papers here. Arey, kya re? What type of questions you are going to ask? Huh? Acha, you have joined later. It's okay, it's okay. KTC syllabus, this is reboot, sir. I am discussing for engineering services exam and ISRO instrumentation, still it is there. Okay. 1.8 you got a. Anyway, we can't take 1.8. We are going for second order, sir. 1 point something means next order. Seal you have to take. Because you cannot have 1.5 delay. Good, good. Most of you answered good. Because it is second order, what is the prototype low pass filter transfer function? I know 1 by s square plus root 2s plus 1 that is available in the slide number. That also will write slide 3. This is the denominator or not with cutoff 1. Prototype low pass filter means with OMC 1 H of s is 1 by s square plus root 2s plus 1. 1 by s square plus root 2 from slide number 3. From the previous slide, from the previous slide only we are saying. From slide number 1 by s square plus root 2s plus 1, sir. Prototype low pass. But for a given question, cutoff need not be 1. That point only we have to check now. For a given question, cutoff need not be. What is that stupid formula? To find out OMC, what is the stupid formula? OMP divided by correct? What happened to our answer? Okay. I want to insert a new slide. Just wait. Fourth one, fifth one, they are looking like same. Right. What is OMC relation for us, sir? OMP divided by 1 by del P square minus 1 whole power 1 by 2n. What is OMP number we got here? What is OMP number? 1. Divided by 1 by del P square means 1 by 0.7017 whole square. Whole power 1 by 2n means order is 4. Sorry, order is 2 or not? Whole power. Luckily, this answer is also 1. Luckily. Because 0.707 means 1 by root 2. 1 by root 2 whole square is what? 2 minus 1 is 1. 1 power anything is 1 or not? Luckily, that answer is good. Actually, if you do perfect simplification, 0.99999 over action, 1 only. That many 0.999 means it becomes. So after completion of second step order and cutoff, third step is what? Convert the prototype filter to required filter. Convert the prototype filter to required filter. What is the required filter asked in the question? Design a digital low pass filter. S place S by OMC or not? Luckily OMC 1. Suppose OMC is 5. See here everyone. If OMC is 5, S by 5 you have to substitute. Be careful. In our question, luckily OMC is. So what is the required filter transfer function for us? That is represented as h dash s, which is same as original 1 by s square plus root 2s plus 1. Same as original 1 by s square plus root 2s plus. From our previous slide, we know what is the prototype filter transfer function, sir. Required filter transfer function also same. What is the reason why required filter transfer function is same? We got OMC as 1. Suppose OMC is 2. In our previous expression s place, s by 2 we have to substitute if OMC is 2. Till here the third step is over. Analog frequency transformations. What is the fourth step? Convert the analog transfer function to digital transfer function. H dash h to h of z. Because it is bilinear transformation, which stupid formula? S to z conversion. Come on, friends. 2 by t into 1 minus z inverse by 1 plus. First step I remove 2 by t. Here also I am removing 2 by t. Here also I am removing 2 by. So what is the digital transfer function now, sir? In this expression, wherever s is there, what we are writing? Just do simplification. Some result will be obtained. Last step we know, if you simplify the transfer function, structure means we can go for a direct form to structure canonical. It is second order. Direct form to structure we can use, sir. This is a simple problem. I have chosen such that we got order as second order, sir. Yes, I hope you have completed the problem. They will not give prototype formula. Video got stuck. Aditya, I am here only. Don't be tensed. They will not give formula, sir. But old papers, what I observed is they have asked for order. They have asked for order. That order stupid formula we have to remember. 1 by 2 logarithm of this one, sir. That you should remember. Okay? Order formula they have asked. old papers. But I mentioned with you yesterday only, they may ask questions conversion of S plane to jet plane. Analog transfer function will be given. Try to get head jet. Analog transfer function will be given. Try to get head jet. See, same problem if you solve by impulse invariant technique, IIT. Same problem if you are solving by IIT, impulse invariant technique. Our first step itself changes. Because in impulse invariant, omega equals to ohm into Ts or not. Order becomes fourth order. If you solve for order, it becomes fourth order. Just I am saying the answer directly. Later on, you solve that question. If you solve the same problem by using IIT, first step itself changes. Omega equals to ohm into Ts. So what is ohm P? Pi by 2 omega P. What is ohm step band? 3 pi by 4. Order becomes fourth order. Fourth order means enjoyment is more. Fourth order transfer function is this s square plus 0.765s plus 1 into s square plus 1.848s plus 1. It means another disadvantage of impulse invariant is what? Not only it is unable to design high pass band stop filter. For the given specification, order is more or not? For the given specification, order is more in comparison with bilinear transformation. For the given specification, order is more in comparison with bilinear transformation. Don't expect complete design. But conversion of h of s to h of z question can be asked. Convert the analog transfer function to digital transfer function, that question can be asked, sir. If order is 1.5, go for second order. 1 point something means second. Seal. Next number, rounding. Okay, I hope you have completed this. I am going to next one. The next form of filter which we are using is called a Chebyshev filter. Chebyshev filter nature is, it can maintain ripples in any one band. If you are maintaining ripples in pass band and monotonic nature in stop band, ripples in pass band, monotonic in stop band, that is called as a type 1 Chebyshev system. Type 1. If you are taking opposite characteristics, sir, that is monotonic nature in pass band, ripples in stop band, it is type 2 or inverse Chebyshev. Now it is monotonic nature in constant level, but ripples in the stop band is type 2 or inverse Chebyshev. It means Chebyshev filter can maintain ripples in any one band. Chebyshev filter can maintain ripples in any one band. Okay? See here. The Chebyshev polynomial is defined as this relation. Cn of ohm equals to cos of n cos inverse ohm for mod ohm less than 1, cos hyperbolic form. One relation cos of n cos inverse ohm. Another relation cos hyperbolic of n cos h inverse ohm. You will not get this question 100% in gate paper. Listen first. On Chebyshev you will not get question. Listen. See, if I substitute n place 0, cos 0 is 1, sir. 0th order means no delay. If I substitute n place 1, cos of cos inverse ohm is ohm. Then the higher order Chebyshev polynomials are generated by this recurrence relation. Cn of ohm equals to 2 ohm, Cn minus 1 ohm, Cn minus 2 ohm. Suppose you want C2, it is 2 ohm, C1 ohm minus C0 ohm. Already C1 ohm is ohm, C0 ohm is 1. 2 ohm square minus 1 is second order. Third order, 4 ohm cube minus 3 ohm. The magnitude square expression of Chebyshev will look like this. 1 by 1 plus epsilon square Cn square ohm. Magnitude square response. There also we have written a formula like 1 by 1 plus ohm by ohm C whole power 2n. What does this epsilon represent? Is variation in the magnitude level. Everyone see this graph? We want ripples in the passband. That ripples in the passband can be maintained because of epsilon. Ripples in the passband. How we are getting the order of Chebyshev formula here is by using this last relation, mod h of j ohm in decibel scale is equals to this relation, sir. By using this relation, minus 20 log epsilon minus 6 into n minus 1 minus 20 n log ohm normalized. Let me explain how we got that formula. In our previous slide, we have written magnitude whole square like this. Okay. First, we are neglecting number 1 compared to the second term. For large frequencies, Cn ohm is approximated as 2 power n minus 1 ohm power n. See here, everyone. In this table, C2 ohm number is 2 ohm square minus 1, sir. Third order polynomial is 4 ohm cube minus 3 ohm. If I am taking ohm number as 50, 50 whole square is more than 1 neglected. 50 whole cube is more than 150 neglected. So for large frequencies, Cn ohm is approximated as 2 power n minus 1 ohm power. Substitute n plus 2 here. If you substitute n plus 2, 2 ohm square, n plus 3 means 4 ohm cube like that. By doing all that approximations, this is the stupid formula we are using to get order of Chebyshev filter. 100% you will not get question. The reason is, after finding the order of Chebyshev filter, you require these tables to know the transfer function of Chebyshev system. Ripple 0.5 dB, ripple 1 dB. What is ripple? Del P. Ripple 2 dB, ripple 3 dB. That variation in magnitude which I have shown, there are how many possibilities you see? 0.5 dB, 1 dB, 2 dB, 3 dB. They should provide these tables compulsory in the GATE exam. Generally, it is not possible. So don't expect any question related to Chebyshev in the exam. Don't expect any question. Okay? Ripples are not unwanted, sir. They will reduce the order. Ripple means don't feel 100% will be there. I will show you. You are expecting magnitude level of 1 or not? It will be slightly more. 1.01 to 0.99. Small variation only. Not above 1 or below 1. Small variation only. 1 plus del P to 1 minus del P. Very small variation. 100% you will not get any question related to Chebyshev. Why? After finding the order by using this stupid formula, to get analog transfer function, ripple is changing, the respective order changes, transfer function changes. Once the ripple changes, respective order changes, analog transfer function also. Just to study the theory of this one. Only theory. What theory? Chebyshev filter can maintain ripples in any one band. But why we need Chebyshev filter is compared to Butterworth filter. IES, once you come to that question, I'll explain 10 problems only on filters. Mains exam. Okay? Don't get emotional. But compared to Butterworth filter, Chebyshev filter for the given specification, it will reduce the order. Suppose del P, del S, omega P, omega S are known, sir. 4 specifications are known for us. If Chebyshev is asking second order filter, Butterworth will ask for 4th order filter. Means it is reducing the order. Correct or not? Like that, first Butterworth, then Chebyshev, then elliptical, then Bessel-Thomson. In compact disc player, CD player, recording is done, playback is done. When you are playing back, instead of digital to analog converter, there we are using a oversampling concept. There we need a Bessel filter. One of our friend is asking what is the application of these filters. In audio signal processing, suppose you are playing CD, compact disc player, CD player, we will have playback and recording, both will be there. In the playback process, instead of using a D to A converter, there we are using a fourth order Bessel filter. Bessel filter is what? Butterworth, Chebyshev, elliptical, then fourth one is Bessel. See the mathematics of Chebyshev. How many pages, how many slides I have given? 2, 3, 4. Compared to Butterworth, maths is increased or not? Compared to Butterworth case, maths is increased. If you go for Bessel, it is 10, 15 pages. Which is best among two means Chebyshev only because it is reducing the order. Always our target is minimize the size of the chip or not. Minimize the size of the chip. So in IAR filter design, my suggestion is you concentrate impulse invariant bilinear transformation techniques. Maybe if they want to give, they may ask for Butterworth order also. Maybe. Chebyshev, I don't encourage you also to solve the problem. I don't encourage. Till now, no question came from Chebyshev. No question came from Chebyshev filter. Okay. That is about IAR and FIR filter design. Sorry, it is not FIR, IAR filter design. Okay. Let me discuss the concept of FIR filters. Let me discuss the concept of FIR filters. Finite impulse response filters. First advantage of FIR systems is what? They can achieve. This topic is most important for instrumentation fellows. Almost every year they will get a question. Listen carefully. Very important topic. FIR. There are 2-3 models. They are repeatedly asking that models only. Listen. They can achieve linear phase response. 100% they are stable. Because all poles lie at Z equals to 0. Any pole of FIR filter is lying at origin, so they are 100% stable, sir. They are 100% stable. We know the transfer function of this FIR filter is going to appear like this. The difference equation form is like this, sir. And the transfer function of FIR filter can be written as Hz equals to sigma 0 to n minus 1 Hn z power minus n. Sigma 0 to n minus 1 Hn z power. Based on the symmetry and the number of samples that are chosen. Based on the symmetry and the number of samples that are chosen, FIR filters can be taken in 4 different forms. Based on the symmetry and number of samples that are chosen, FIR filters can be taken in 4 different forms. Listen that. Type of the filter, symmetry, length. Length means number of samples that are chosen, sir. If you take type 1 FIR system, it will have even symmetry with odd length. What does it mean? Suppose I have drawn this impulse response graph. Everyone tell me, it is looking like even symmetrical signal or odd symmetrical signal, sir. See the graph and tell me. It is looking like even symmetrical signal or odd. It is 100% even with respect to which sample? N equals to 2. How many number of samples are there, sir? 5 samples are there. Even symmetry with odd length is taken as type 1 system. Type 2 system means even symmetry with even number of samples. Even symmetry with even number of. Type 3 system means odd symmetry with odd number of samples. Odd symmetry with odd number of. Type 4 system means odd symmetry with even number of samples. So based on the symmetry and the length means number of samples chosen. Number of delays that are chosen. FIR filters can be taken as 4 different types. Even symmetry with odd number of samples, type 1. Even symmetry with even number of samples is type 2. Odd symmetry with odd number of samples is type 3. Odd symmetry with even number of samples is type 4. First, everyone take a snapshot of this slide, sir. We are going to solve now 2 questions on this point. Take a snapshot of this slide first, everyone. Based on the symmetry and the number of samples that are chosen, FIR filters can be taken. FIR filters can be taken as 4 different types. Have you completed the snapshot, everyone? What we studied already, FIR filters can have linear phase only when the impulse response is symmetric or anti-symmetric. That point only again we are checking, nothing new, sir. I hope you have completed the snapshot because I want to solve one model. Come on, friends. You have completed a? Let us discuss this question. Find the transfer function and h of e power j omega frequency response for the given impulse response expressions. Different impulse responses expressions are given. We should decide what is the type of the FIR filter and nature. Type can be decided by the stable or not. Type can be decided by the stable. Everyone tell me, H of n is a set of 101. First it is acting like which filter? You should tell me. Low pass, high pass, band stop. Come on, friends. Everyone solve for the transfer function and tell me. N varies from 0, 1, 2. So what is the transfer function? You can write 1 plus z power minus 2. To decide the nature of the filter, which values we are solving? Z plus 1, 1 plus 1, 2. Z plus minus 1. That is also 1 plus 1, 2. Starting ending same means it is a band stop filter or not? 1, 0, 1. It is exhibiting even symmetry with respect to n equals to 1. It is exhibiting even symmetry with respect to n equals to 1. Okay. Odd samples, only 3 samples are there. Only 3 samples are there. So, which type? You have taken already snapshot, respond. Even symmetry with odd number of samples means which type? Come on, friends. Type 1. Type 1 system or not? Okay. Low pass. Starting ending same means band stop, sir. Starting ending same is band stop system. How to define 1, 2, 3? Already have shown here. Na? Type 1 means even symmetry with odd number of samples is called as type 1 FIR system. Even symmetry with even number of samples is type 2 system. From the table only we are defining. In this example, we have even symmetry with odd number of samples, type 1 system. Think about the second bit, sir. H of n equals to set of 1, 2 to 1. Everyone should tell me nature and type for each bit. B bit is nature what, type what? What is the transfer function of this one, sir? 1 plus 2z inverse plus 2z power minus 2 plus z power minus 3. Starting how much? 1 plus 2 plus 2 plus 1 is 6. Ending how much? 1 minus 2 plus 2 minus 1, 0. Starting 6, ending 0. Low pass. Which type? Don't say your type. Is it type 1, type 2, type 3? Or type 4? That is a question. We have even number of samples with even symmetry, but it is symmetric with respect to 1.5 value. It is looking like symmetric with respect to 1.5 value. Even symmetry with even number of samples. Come on, friends. Which type? Type 2 from the table. Even symmetry with even number of samples. Think about the third bit, sir. Come on, friends. Third bit. Third bit transfer function is 1 minus z power minus 2. N value 0, 1, 2. H of z at z equals to 1 is how much? 0. Z equals to minus 1 is how much? That is also starting ending 0 band pass. Which type after sketching the graph? Odd number of samples with odd symmetry. Odd number of samples with a odd symmetry means type 3. Tell me. Odd number of samples with odd symmetry, type 3. Probably every one of you liked this question. There is a reason emotionally you are giving the answer. Good, good. Just a minute. I have to make one adjustment. Yes. What is the last set of data given, sir? 1 minus 2, 2 minus 1. 1 minus 2. It means what is the transfer function you are writing? 1 minus 2z inverse plus 2z power minus 2 minus z power minus 3. Starting how much? 0. Ending how much? 1 plus 2 plus 2 plus 1, 6. Starting 0, ending 6 means high pass filter. Type 4. If you want, you check. Odd symmetry with even number of samples. Odd symmetry with even number of samples is type 4 system or not? %, this question can be given. Why? 4 options are available. The following impulse response or transfer function corresponds to which type? To answer this question, this enjoyment you can do. Filter nature. You must be thorough with this table. Correct or not? Must be thorough with the table, sir. That is important. Okay. And one more conclusion we can make here is, if you want to design a band stop filter 100%, it is possible only with the type 1. If you want to design FIR band stop filter, 100% it is possible with only type 1. How I am saying? Type 2 case, ending answer 0. Type 3 case, starting ending 0. Type 4 case, starting 0. But band stop expectation is what? Starting ending answer must be same. So what conclusion we can make here is, with respect to type 1, all forms of filters can be designed. With respect to type 1, all forms of filters can be designed. But band stop filter is 100% possible only with type 1. No other type can form band stop filter. In type 2, which quantity is 0, sir? H minus 1 is 0. Ending answer 0. H minus 1. Ending answer 0 means you cannot design which filters? High pass and band stop. You cannot design high pass and band stop. Type 3, from this example, what we observed? Starting ending the answer is 0. Starting ending the answer is 0. But type 4 case, what we observed? Starting the answer is 0 or not? Starting answer is 0 means you cannot design a low pass filter. With the type 4, you cannot design a. If they want to give the question cleverly, they may frame the question like this. If they want to give the question cleverly, which of the following filters are not possible under type 1, are not possible under type 2? This thing we know, basic table we know, low pass means 1, 0, high pass means 0, 1. Based on that, automatically we can create or not. But you must be thorough with this table. If you are not thorough with the table, you cannot answer the question. If you want, make a note there, sir. Band stop filter is possible only with the type 1. Band stop filter is possible only with the type 1. Band stop filter is possible only with the type 1. With the type 2, what is the conclusion? As ending value 0, H minus 1 is 0. You cannot design, as H minus 1 is 0, we cannot design high pass filter and band stop filter. Okay? With the type 2, we cannot design high pass and band stop filters. I am moving to next example. Please answer everyone this question. The first few values of the impulse response of a linear phase filter are given, assuming the smallest length. Tell me the overall set of data, assuming the smallest length. Type 1 means what we have to obey, sir? Even symmetry with odd number of samples or not? So 2 minus 3, 4, 1. Come on. Next set will be 4 minus 3, 2, assuming the smallest length. It is looking like even symmetric with respect to one of the middle sample. 4, 4, minus 3, 2, 2. It is 100% obeying even symmetry with the odd number of samples. The question, it is framed assuming the smallest length. Assuming the smallest length. He has given beginning samples. He wants the complete set of samples. He has given the beginning samples, complete set of samples. अरे उसमें क्या है रे? Type 2. For type 2, what we observed, H minus 1, 0. Ending 0 means high pass filter ending we want maximum value. So high pass filter cannot be designed. Band stop also we want some number. As it is 0, band stop filter is not possible. Type 4 case, what happened? H1, 0. Starting itself is 0 means low pass filter is not possible. Low pass filter is not possible. Similarly, band stop filter is also not possible. What is there? You know basic table na, filter table, you know. Low pass means 1, 0, high pass means 0, 1. Magnitude levels we studied or not, sir? Type 1 means even symmetry with odd number of sample. This circled sample, with respect to the circled sample, it is obeying even symmetry, sir. Come on, friends. Answer me. Type 2. Type 2, what is our expectation? Even symmetry with even number of samples. So what is the answer I should write for type 2? 2 minus 3, 4, 1, 1, 4 minus 3, 2. 2 minus 3, 4, 1, 1, 4 minus 3, 2. Total 8 samples are there. It is obeying even symmetry with even number of samples. But it is looking like even symmetric with respect to a non-integer sample, a non-integer value, which is not there. Between 1, 1, there is a non-integer sample. We should obey even symmetry with even number of samples. That is type 2 nature or not? At least respond type 3 answer. Come on. Respond type 3 answer. Think. I will tell the answer. First you think. What is type 3 answer? Odd symmetry with odd number of samples means, come on. 2 minus 3, 4, 1, 0. You should take 0, sir. 2 minus 3, 4, 1, 0. Minus 1, minus 4, minus 3, minus 2. For any odd signal, the amplitude is 0 at origin point. If it is anti-symmetric with respect to n equals to 3, there it must be 0. 0 must be included. For any odd signal, the amplitude is 0 at the origin point. Origin in the sense, if it is anti-symmetric with respect to phi, their amplitude must be 0, sir. Last question, type 4 answer is without that 0, sir. Odd symmetry with even number of samples means without the 0 number of type 3 answer will be there. Good, most of you answered, good. But again, to answer this example also, background is what? That slide. Background is that slide or not? Beginning samples are given by assuming the smallest length. Find the complete set of data is the question. Let me discuss the next point. I hope everyone completed 14 slides here. 14 slide is over. In the last case, it is anti-symmetric between 1 and minus 1, sir. With a non-integer sample, it is anti-symmetric. Don't be tensed. Type 2 case, type 4 case, it is anti-symmetric with respect to non-integer value. Like 3.5 or 4.5. But our phase spectrum is continuous spectrum only, no problem. In discrete case, you can take phase angle as minus 3.5 omega, no problem. Draw this graph. Last example graph only you draw. At 0 it is 1. At 1 it is minus 2. 2 it is 2. 3 it is minus 1. It is anti-symmetric with respect to with sample 1.5, like that here also. But type 3 case, neatly it is anti-symmetric with respect to integer sample or not. After explaining this example also, you are getting, here it is anti-symmetric with respect to non-integer value. But type 3 case, it is anti-symmetric with respect to integer sample. That way, same thing happened here. Same thing happened here. Type 2 and type 4 case, they are maintaining symmetry or anti-symmetry with respect to non-integer sample only. Okay. Oh, last one -2, good correction. No one is speaking. Odd symmetry with what? I should change the sign now. Written +2. Good, yeah. Thank you. I have not changed the sign there. 2 becomes -2. What more, bacha? 2 - 3, 4, 1, 0. How to maintain anti-symmetry with respect to 0? 1 becomes -1, 4 becomes -4. Why I have increased the length? Because of the type, this length came. I have taken smallest length only. More than 10 times the topic which we are discussing now is asked for instrumentation bachas in GATE exam. What is the location of zeros of a linear phase FIR filter? What are the location of zeros of a linear phase FIR filter? Linear phase meaning is obeying symmetry or anti-symmetry plus or minus h of n minus 1 minus n, where capital N is the length of the impulse response. Where capital N is the length of the, if you take plus sign, it is symmetric. If you take minus sign, it is anti-symmetric. Like this. Suppose you have chosen Hn equals to h of n minus 1 minus n, sir. H0 sample equals to h of n minus 1. H1 sample equals to h of n minus 2. Like the last two problems we solved. If you take plus sign, it is like even symmetric. Minus sign means odd symmetric. Listen. What you can say, the statement is, whenever Z0 is a root of a 0 of FIR filter transfer function that has a linear phase, then Z0 inverse is also a 0. Whenever Z0 is a 0 of h of z, Z0 inverse is also. How this is correct means, listen here. Internally, I am taking minus sign common. Internally, I am taking minus sign common, minus of n minus n minus. Everyone recollect how we studied time reversal property in Z plane? H of minus n means what is the Z transform will write? H of Z inverse. What is the time shifting property in Z plane, sir? Z power minus n naught into Hz. Z power minus n naught into. If I apply Z transform here, Hn becomes Hz plus or minus. H minus n becomes what? H of Z inverse. Shifted by n minus 1 means what is the extra multiplier? Z power minus of n minus 1. So this side Hz is there, this side also H of Z inverse is there. This is representing what for us? Linear phase. Z plus e power j omega if we substitute, that is extra linear phase. In e power j theta, what is the phase for us? Minus omega n minus. For a linear phase, for a linear phase FIR system, whenever Z0 is a 0, automatically what is other 0? That is what we observed. This side Hz is there, this side H of Z inverse is there. Both are equal with linear phase. Extra linear phase are not. So what is the conclusion we can make here is, if I want to take a 0 at -1, automatically what is the other 0? For linear phase system, 1 by -1 is -1 again. If Z2 is a real 0, if Z2 is a real 0, What is Z2 inverse? Suppose I have taken a 0 at 3, sir. If I have taken a 0 at 3, what is the inverse 0? 1 by 3 is the answer or not? 1 by 3 is the answer. Okay. How it becomes Z power plus bacha n minus n naught form. One time I have done mistake, every time I will do a n minus n naught form bacha Z power minus n naught. First folding, then shifting. Z power minus of n minus 1 only. Every time I will not sleep. If Z3 is a complex 0, having its magnitude 1, sir, then Z3 inverse is Z3 conjugation. If you take a complex 0 with magnitude 1, Z3 inverse is Z3. And the last condition is if Z4 is a complex 0, if Z4 is a complex 0 with the magnitude not equals to 1, above 1 magnitude equals to 1, what are the roots is Z4, Z4 inverse and conjugation of both. If you take a complex 0 with magnitude not equals to 1, what are the roots? Original, inverse, conjugation of both. This is the conclusion we can make. But this is not valid for every FIR system, only for linear phase FIR. For a linear phase FIR system, whenever Z0 is a 0, automatically what is other 0 means? Z0 inverse. Z0 inverse. So what is the conclusion? Suppose I want to locate a 0 at minus 1. What is the inverse of that one, sir? Again, minus 1. If I want to take a real 0 like 2, what is the inverse 0? 1 by 2. If Z3 is a complex 0 with magnitude 1, what is the inverse root? Conjugation. If Z4 is a complex 0 with magnitude not equals to 1, what are the roots? Original, inverse, conjugate, inverse, whole conjugate. First you take original, inverse, directly conjugation of them. That is a conclusion we can make. अरे फिर भी वही पूछ रहे संजीव, बताया ना, FIR filter has linear phase means the indirect requirement is impulse response must be symmetric or anti-symmetric. DTFT, one hour we discussed that topic here. Every FIR filter cannot have linear phase. If FIR filter has linear phase, our definite requirement is symmetry or anti-symmetry. That is what I discussed so many times with you. FIR filter has linear phase means our definite requirement is this condition, which is called as symmetry or anti-symmetry. Symmetry or anti-symmetry. Everyone take a snapshot of this slide. We are going to solve some questions on this. Take one snapshot. Come on, friends. Uh, 14F fellow, take it. 15F, I think everyone completed a snapshot. 15F. Please answer this question. Left side question first. A linear phase FIR filter has. Arey, wait karo ma. Finally, I'll give. Some fellow has asked previous slide. 12F is empty ma. Nothing I kept. Okay. A linear phase FIR filter has one of the 0 at 1 by 2 e power j pi by 3. Find the remaining zeros. Neat hint is given linear phase word. Linear phase word. So it is a complex zero with magnitude not equals to 1 or not. Complex zero with magnitude not equals to 1. It is coming under last condition. Everyone see the cursor, sir? It comes under the last condition or not? Come on, friends. So what is the answer? 1 root 1 by 2 e power j pi by 3 original. Take inverse 2 e power minus j pi by 3. Then conjugate of them. Original root inverse, take conjugate of them. Original root inverse, conjugate of them. It is a complex zero with magnitude not equals to 1. It is a complex zero with magnitude not equals to 1, sir. So first original root we have written, then inverse. Take conjugation of both of them. Take conjugation of both of them. This question is funny. Transfer function of fourth order linear phase. It is not fourth type, study properly. Fourth order. Transfer function of fourth order linear phase. FIR filter is given by this expression. Then what is GZ answer? What is G object? See, by elimination process we can answer this. By elimination process. 100% there is no chance for B and C. How I am saying, because of the coefficients they have 1 by 2, 1 by 3. When you multiply with this original function, they cannot form symmetry or anti-symmetry. Option D also no chance. How I am saying that point? If I multiply the original transfer function with option D, sir. If I multiply the original transfer function with option D, first one 1 into 1, last one 9 z power minus 4. 1 and 9 number form symmetry. Come on, bachas. When you multiply the same transfer function again, 1 and 9 cannot form symmetry, na? So this is also wrong. Automatically, what is correct? Again, the beauty is linear phase word. Again, the beauty is linear phase. See here, 1 plus 2z inverse plus 3z power minus 2 into 3 plus 2z inverse plus z power minus 2. If I expand first term 3, 1 into 3, last term 3z power minus 4. Az inverse, az power minus 3, bz power. It is symmetric with respect to 2. It is symmetric with respect to 2 or not? It is symmetric with respect to what break? Another 20 minutes only. You want break? Another 20 minutes I am discussing. Wait. Till 4:30 only I said na. This is a habituated regular question. How you deleted choice, sir? Dekho beta. B and C, they contain 1 by 2, 1 by 3. If I multiply by 1 by 2, 1 by 3, I will not get symmetry or anti-symmetry because the word linear phase is used. Why last option wrong? Here I have given explanation why the answer is wrong. If I want to repeat the same GZ transfer function again, sir, 1 into 1 becomes 1, 3 into 3 becomes 9. Symmetry means first coefficient, last coefficient must be same. That is also not happening. Automatically option A is correct. Linear phase word is used means compulsory symmetry or anti-symmetry is requirement. It is compulsory symmetry or anti-symmetry. Okay. Almost every time they'll give this question, sir. In one exam, he has mentioned a linear phase. FIR filter has 108 3 plus J4. Which of the following is not the correct zero? There only is giving hint for you. If 10 is 3 plus J4, what is the magnitude? 5. Complex 0 with magnitude 5 means it is coming under again our last condition. So out of the 4 options given there, 3 must be correct, 1 must fail or not. A linear phase FIR system has one of the 0 at 3 plus J4. Which of the following is not the correct 0 means 3 options must be correct. Never forget this point. For a linear phase FIR system, whenever Z0 is a root, what is other root? Z0 inverse. From this expression, we have made that conclusion. If I want to look at 0 at minus 1, inverse 0, opposite minus 1. If I want to take a real 0 like 2, sir, Z2 equals to 2, if I assume 1 by 2 is the answer. If I want to take a complex 0 with magnitude 1 like J, if I take J, minus J is the other answer. If I want to take a complex 0 with magnitude not equals to 1, like this problem we solved, it is a complex 0 with magnitude 1 by 2 means not equals to 1. Original root, inverse, conjugation of them. Original root, inverse, and conjugation of. Okay. To design FIR filter, we are using a technique called as windowing method. Why window is needed means, listen, ideal low pass filter can maintain constant magnitude with linear phase. Ideal low pass filter can maintain constant magnitude with linear phase. But the problem with this is what? Its inverse Fourier transform is sin omega Cn by pi n delayed by alpha samples. Sin omega Cn by pi n delayed by, it is having constant gain, sir, but having linear phase, it is non-causal in time domain or not. That function is non-causal in time domain. To make this non-causal impulse response as causal, means physical form, we are multiplying it with a window that is defined for certain length 0 to n minus 1. To convert this non-causal impulse response to causal impulse response, we are multiplying with a specific window. That is defined for 0 to n minus 1. If this answer is multiplied by 0 to n minus 1, automatically it is there only for positive length FIR system or not. But the desirable characteristics of window, when you can say you have chosen the best window means it should maintain narrow main lobe width. Main lobe width must be minimum, sir. Side lobe energy tending towards 0 as omega tends to plus or minus pi. When you draw the spectrum of the window, if these 2 points are obeyed, then you can feel it is the best window. Narrow main lobe width must be minimum. Side lobe energy is tending towards 0 as omega tends to plus or minus pi. Listen everyone. In that process, the first window which we are choosing is called as a rectangular window. The first window which we are choosing is called as rectangular window. Listen friends. If I take rectangular samples with amplitude 1 from 0 to n minus 1, sir, if I multiply our previous answer, this SAP function answer with this window, automatically this is defined only for what length? 0 to n minus 1, which can be implemented or not, achieving linear phase. But how we are going to check these 2 points means we should calculate the Fourier transform of this one, DTFT of this one. W rect e power j omega is sigma 0 to n minus 1, its amplitude 1 e power minus j omega, and this enjoyment we have done in the DTFT starting only, discrete time Fourier transform starting only we have done. E power minus j omega n minus 1 by 2 multiplied by sin omega n by 2 by sin omega by 2. DTFT first. When you are seeing the old slides, you check it. Generally we solved rectangular window DTFT. Listen, if I try to draw the magnitude spectrum of this window, sir, if I try to draw the magnitude spectrum of this window, it is going to appear like this, roughly. It is having narrow main lobe width only, but side lobe energy is not negligible. Its main lobe width is 4 pi by n. How I got that? Sin omega n by 2 equals to 0 means what is the general solution? Plus or minus m pi. Solve for omega. It is maintaining narrow main lobe width, but the peak side lobe level is 13 decibel less than the main lobe number. How I am saying that answer 13 dB exactly from Parseval's theorem? It means, according to our previous slide, first point obeyed, second point is failed. Side lobe energy is not tending towards 0 as omega tends to plus or minus pi. But we have maintained narrow main lobe. Then the best form of window is barlet or triangular window. Every one of you know triangular window means convolution of two equal length rectangles or not. Then the best window Hamming, Hanning, Kaiser, Blackman. What you are going to get in the exam is not these formulas. Comparison of window characteristics is a definite question for you in the exam. These numbers which are framed as a table, no one can change them in the world. They are all fixed, sir. No one can change them. Comparison of window characteristics is a definite question for you. See, for rectangle in the previous slide I have shown you. Narrow main lobe width will be 4 pi by n. Immediate side lobe level is 13 dB less than the main lobe amplitude level. That is what here I have shown. Minus 13 dB means 13 dB less. What is minimum stop band attenuation? The fourth one here is as omega tends to pi, what is the answer? As omega tends to pi, the answer becomes minus 21. Barlet or triangle. Barlet, other name triangular window. What happened is 8 pi by n. That is not a big story. Here 4 pi by n becomes double because it is convolution of two equal length rectangles or not. 8 pi by n. Peak side lobe level is somewhat better, minus 25 dB. Minimum attenuation also like that. Hamming and Hanning, they are combinedly called as raised cosine windows. Hamming and Hanning, they are combinedly called as raised cosine windows. Because once you draw them, their graphs will look like raised cosine windows, sir. Once you draw them, their graph will look like a raised cosine window like this for 0 to. In the case of Hanning fellow alpha is 0.5, sir. But Hamming fellow alpha is 0.54. Alpha is 0. See here. One formula of Hamming formula is 0.54 minus 0.46. Hanning both 0.5. Here only if you substitute alpha 0.5, 0.5, 0.5 means Hanning window. Hanning window. But in the case of Hamming 0.54, 0.46. How we got all these numbers means for every window formula you should calculate DTFT. That is not possible with you or with me. So much emotion is needed. Calculation of spectrum of these functions. Better to remember this table. It is a most important table with respect to ISRO and IES exams. ISRO paper IES already some questions are touched on this. GATE only one time a question asked. What is the peak side lobe level of rectangular window means minus 13 decibel. What is the meaning of peak side lobe level? Immediate to the main lobe. As omega tends to pi, if you are checking the value, that is called as minimum stop band attenuation. Again, why we require all these windows? Obeying these 2 points. What are the 2 points to be satisfied? Narrow main lobe width must, side lobe energy must tends towards 0 as omega tends to plus or minus pi. So out of all window formulas we have taken, narrowest main lobe width is for which window? Narrowest main lobe width is there for which window, sir? Rectangle. Less side lobe level for which window? Blackman case minus 57 means minus 60 dB, 0.001. That is not a big matter. Main lobe width increases means side lobe energy is reduced or not. See the main lobe width in the case of Blackman. Compromise between the characteristics means we should go for which window? Hamming. Compared to Hamming is better because minus 41 here, minus 31 decibel. Everyone should remember this table. If you don't want to remember the table, derive. In the exam, I'll derive. This table questions as it is will be asked in ISRO paper. IES also they may frame. Rectangular window means peak side lobe level minus 13 decibel. Minimum stop band attenuation minus 21 dB. No one can change that number. No one can change that number, sir. You should remember it. Okay. First, everyone take a snapshot of this one. I am going to solve one ISRO question on this. FIR filter design using windowing method is not a gate question, but window characteristics comparison is a question. They can frame easily these numbers. Okay. So previous slide I have given window formulas only for rectangular window. I have shown rough spectrum graph. Other windows how we got means after calculation of Fourier transform only we will know the answer. After sketching the spectrum only we will know the answer, sir. If you take a snapshot, I'll give that ISRO question. You should answer me. Have you completed everyone's snapshot? If you derive to 2021 becomes 2022. You cannot do anyway. Okay. One girl is full emotional. Today's last problem. Always when the class will start, when the class will end. When the class will start, when the class will end. Regular question. I am shouting from my side with full emotion. You are shouting for a different thing. Okay, Chodda. Just for fun, I am saying. Everyone, have you taken the snapshot? Let me give that question and answer me. Find the number of delays. He has mentioned that as tap. Because delay is also called as a tap, sir. Required to realize an FIR filter with passband frequency 10 kHz, stop band frequency 15 kHz, sampling rate of 200 kHz. All this data is given in ISRO paper. It is not created by me. Find the number of delays required to realize an FIR filter with passband frequency 10K, stop band 15K, sampling rate 200K, 0.1 dB passband ripple, minimum 60 dB stop band attenuation. Number of delays means he is asking for order. Number of delays means he is asking for order, sir. That only I am discussing Shuryams Dubey. Wait करो. ये problem है आपको पता होता. Wait करो. That only I am discussing now. Without mentioning window name, this data is given. He has not mentioned the window name. Observe the snapshot you have taken our previous slide, you will get the idea. Which window to be used? Number of delays means order. Order depends on transition width. Transition width meaning is Pass band to stop band gap is called as which width? Transition width. Pass band to stop band. As that fellow has used the word 60 dB stop band attenuation minimum, it corresponds to Blackman window. How I am saying that, sir? Blackman case, what is that number? Everyone see my cursor. See here. Blackman case, it is minus 74 decibel. In the other window, Hamming case, minus 53. But he is expecting minimum stop band attenuation of how much? Attenuation means negative sign. Gain is positive. Attenuation is 1 by gain. Blackman window. In the case of Blackman window, what is the stupid formula? Transition width formula is what? 5.5 pi by n. In the case of Blackman window, transition width formula is 5.5 pi divided by n. How to get a transition width means first you normalize the frequencies. What is our normalizing formula? 2 pi f by fs. Use that and normalize. 2 pi into 10 by 200. What about omega stop band? 2 pi into 15 by 200. This becomes 0.1 pi. This becomes 0.15 pi. First you normalize the frequencies. After that, what is the difference? Del omega is what? 5.5 pi divided by del omega. Del omega meaning is what, sir? Pass band to stop band gap. Omega SB minus omega PB. So 5.5 pi divided by 0.15 pi minus 0.1 pi. That is 110. 110 delays are needed. Okay. This is an excellent question because generally the fellows who are not studying our table Okay. Sorry, the power is gone. The fellows who are having doubts, they can stay back. But to answer the last problem we solved, compulsory you must be thorough with what, sir? Comparison of window characteristics. Otherwise, you cannot solve the problem or not. So 110 is the order we got. 110 is the order we got. Those who have doubts, they can stay back. Rest of them, they can leave. Happy Vinayak Chauthi. Enjoy your day. Sunday we'll meet again at 9 o'clock. All the best. Okay. Sunday we are meeting again at 9 o'clock. Yeah, session is over for today. I am discussing DFT and FFT on Sunday. Those who have doubts, they can stay back. Sorry for the power problem that is caused.
Sir, can you just explain that second last page graph?
What second last page?
This peak side lobe level and that I
This one, if you equate the upper term, sin x equals to 0 means what is the general solution? Omega equals to plus or minus 2n pi, na?
right.
Draw karo. Compared to the main lobe amplitude, it is 13 decibel less. This
Okay.
is called as peak side lobe level. As omega tends to pi, whatever the amplitude you are getting, that is called as minimum stop band attenuation. It means peak side lobe level, minimum stop band attenuation, they are not same, sir.
Right.
Yeah.
That is the transition width, no, sir, from pi to pi by n.
Transition width is different. This spectrum we have drawn for what? Pass band to stop band. This middle gap is transition width.
Right.
That
Okay.
is different. This is different. Don't mix.
That was the question. Where for what is the transition band width?
Yeah.
It was. I just wanted to ask. Okay.
Over.
Yes, sir. Thank you, sir.
Hello. Yes, sir. Good evening, sir.
Tell me, ma.
Sir, can you please explain about the window, sir? I didn't get you.
Window, what is the need? This ideal filter, rectangular spectrum has constant magnitude with linear phase. FIR filters are basically designed for linear phase or not. But the problem with them is whatever the time domain function we are taking is non-causal. How to make it as causal means multiply this answer with a specific window. That window must be defined for some finite length 0 to n minus 1, 10 samples, 15 samples like that. But when you can say we have chosen the best window means we should obey 2 points. Narrow main lobe width is 1 point, side lobe energy tends towards 0 as omega tends to plus or minus pi is other point. So in that nature, first window we started is rectangle ma. After obtaining the spectrum, we felt it is maintaining narrow main lobe width only, but side lobe level is not negligible. Means first point satisfied, second point is still not satisfied by rectangle. That is the reason that next best window Bartlett. So many windows we have taken. We have done comparison here. So in this table, which window has the less side lobe level? Rectangle. Correct or not? Sorry.
Yeah.
Which window has less main lobe width? Rectangle. Which window has less side lobe level? Minus 57. Compromising between the two characteristics means we can go for which window? Hamming.
Hamming, yes.
Okay. That is what window means.
Yeah. And one more doubt, sir. 17F page number. Sir, the table, like whatever values are there, can you prove it, sir? Like the one.
We can prove. You should take the DTFT. This is multiplied by exponential. Draw the spectrum.
Okay.
That is not that much easy. You can try.
Okay, sir. Thanks.
Right.
Hello.
Sir,
I wanted to ask, means like in that for when making causal, non-causal to causal, you told that narrow main lobe with that narrow means what it is.
narrow means reduced width. Yeah. What we proved under Parseval's theorem, maximum energy or power must be there only in the low frequency region. Na?
Oh,
Narrow means reduction.
okay. Yes.
That way.
Sir, answer. Second part is like means location of zeros you told. Z0 is a zero of adjacent,
Yes,
Z0 inverse. That how, sir? Means like.
That we proved, na? Left side H of Z is there, right side H of Z inverse is there. Without this
Sir, I
linear
lost connection, sir.
a linear phase छोड़ करो hz equals to h of z inverse without linear phase. Means if z naught is a root this side, z naught inverse is also a root only.
Okay.
That
Okay,
way.
okay. Yes, sir. Yes, sir. Okay, sir. Okay. Thank you, sir.
Sir, have they asked any question related to last question, the same question?
They will ask that type of models only in ISRO exam. Till now, no one has asked. Even GATE also, they have not touched that model.
Only one question has been asked in ISRO.
Yes, yes. Till now. Next year, they will further improve also.
Okay. Thank you, sir. Bye.
Yes,
Hello,
ma'am.
sir.
Yes, ma'am.
Sir, in the last problem, minimum 60 dB stop band attenuation. Why we are taking Blackman window, sir? Why not
What is
Hamming
the number
window?
of that one? Minimum 60 dB means you require minimum minus 60. Hamming window has how much? Only 53, na? What is
Yes,
the
sir.
statement mentioned? You require minimum 60 dB stop band attenuation means the chance is there only for Blackman. Hamming has minus 53, but you are expecting minus 60 minimum.
Okay.
That is the reason Blackman is sufficient for that.
Okay, sir. Sir, and you said that when we need magnitude approximation, we will go for designing
IAR, yes.
IIR filter, right, sir?
Ah.
So what is this magnitude approximation mean? You said
10 parameters, basic characteristics I have told you. IAR filter is magnitude, FIR linear phase. Another
Yes.
thing, IAR filter cannot be designed in digital domain. If you are available with only discrete relation structure, you should go for FIR. If phase is not a concern, you can go for IAR. For the given specification, if you want to reduce the order, FIR can also have magnitude approximation, but if FIR is asking for 15th order filter, same problem with IAR is possible with third order. There are 10 parameters to be compared before starting the design. Then you will know which is best suitable.
Okay, sir.
Okay, we cannot decide directly. For your understanding at this level, I told you one point that magnitude approximation means IAR, linear phase means FIR.
Okay, sir.
Okay.
Sir, and why the name bilinear transformation, sir?
Nothing is there. Oh, it is a one-to-one mapping. In maths also we are using that.
Okay, sir. Thank you, sir.
Still one more is there. हाँ? अभी बताया ना आपको? Okay. Bye everyone.